Space itself holds secrets wilder than any fiction. Our journey to the stars is packed with moments of sheer absurdity and breathtaking wonder. By the end of this, you will know 30 of the most bizarre and amazing truths about our cosmic backyard. We will uncover why the moon smells like a spent firework and how a cemetery formed on Mars. What single fact about space completely reshapes how you see the universe? Astronauts return from their missions just a little bit taller. This is not a myth, it is a direct and peculiar result of living without gravity. In the microgravity environment of space, the constant downward pull we experience on Earth simply vanishes. This allows the vertebrae in your spine, which are usually compressed together, to expand and decompress. Think of your spine as a coiled spring that is finally allowed to stretch out to its full length. This spinal elongation can add up to 2 full inches to an astronaut's height. It is a temporary change, a fleeting gift from the cosmos. The human body is not designed for this permanent stretch, and once back under the influence of Earth's gravity, the spine gradually compresses back to its original length over a period of weeks. This return to normal is often accompanied by significant back pain and a higher risk of disc herniation as the body readjusts to bearing its own weight again. So while floating among the stars might make you temporarily taller, it is a reminder that our bodies are profoundly, intrinsically linked to our home planet. That temporary height boost comes with its own set of earthly reminders, and none is more peculiar than the smell astronauts brought back with them. The moon has a distinct and surprising odor. After the Apollo astronauts completed their moonwalks and clambered back into the lunar module, they reported a strange scent clinging to their suits and the dust that coated them. It was the smell of the moon itself, and they described it as something familiar yet entirely out of place, like spent gunpowder or the wet ashes of a campfire. This was not the scent of ancient rock in a vacuum, but something reactive and almost metallic. The culprit is the lunar soil, a substance scientists call regolith. This is not like Earth's dirt, soft and weathered by wind and water. Lunar regolith is a brutal, sharp powder, the result of billions of years of meteorite impacts that have pulverized the surface into fine, jagged glass. When the astronauts walked on it, they were grinding these tiny shards even finer. The mystery of the smell only appears when this dust meets oxygen. Inside the pressurized cabin of the lunar module, for the first time, the fractured surfaces of these silica particles reacted with the air, a process called oxidation. It is the same kind of chemical reaction that causes metal to rust, and it released that acrid, gunpowder-like aroma. So the scent of the moon is not a passive quality, but a ghostly echo of violence, a smell unlocked only by human presence, telling a story of cosmic bombardment written in shattered glass. That ghostly scent of lunar gunpowder is a memory locked inside a spacesuit, but on Mars, the remnants of our curiosity are left out in the open for anyone to find. The red planet is home to a silent, scattered cemetery. When a robotic explorer like NASA Phoenix lander completes its mission, it does not get a grand funeral or a return ticket home. It is simply left where it last operated, a permanent monument to its own journey. Phoenix touched down in the northern plains of Mars in May of 2008, its mission to dig into the icy soil and search for the building blocks of life. For 5 months, it analyzed the Martian Arctic, confirming the presence of water ice just below the surface before the harsh Martian winter arrived. With its solar panels starved of sunlight, the lander fell silent, and there it remains, a quiet sentinel in the vast, cold desert. This is both a practical necessity and a profoundly poetic reality. It is too difficult and expensive to bring these robotic pioneers back to Earth, so they become part of the landscape they studied. They are our first outposts, the initial pieces of human technology on a world we hope to one day walk upon. Future human explorers, when they finally set foot on the rusty soil, will not just be visiting a new planet, they will be archaeologists of our own ambition, able to walk up and touch the very machine that first tasted Martian water, a historic site preserved in the thin, cold air of an alien world. While our robotic sentinels rest in the cold Martian dust, another world nearby is caught in a perpetual atmospheric frenzy. Venus presents one of the solar system's most bizarre meteorological puzzles. Its entire atmosphere is racing around the planet at a terrifying speed, a phenomenon scientists call superrotation. Picture a planet spinning in slow motion, so lethargic that a single day on Venus lasts 243 of our own. Now imagine its atmosphere, a thick, toxic blanket of clouds whipping around the entire globe in just 4 Earth days. This means the winds screaming through the upper atmosphere of Venus are moving faster than the planet itself rotates. These are not gentle breezes, they are sustained, hurricane-force winds that could effortlessly circle our own world. The Japanese space probe Akatsuki has given us stunning views of this perpetual storm, its images showing the planet's cloud tops swirling in a vast, violent vortex. How can the air move faster than the ground beneath it? It defies our everyday experience. On Earth, friction with the surface and mountains slows the air down. But on Venus, with its incredibly smooth surface and dense, uniform atmosphere, there is little to stop the winds once they are set in motion. The sun's heat, absorbed by the planet's dark side as well as its light side, seems to power this relentless atmospheric engine, creating a global hurricane that has raged for billions of years, a permanent, chaotic shroud over a strangely still world. While Venus hides beneath a shroud of swirling clouds, another world nearby wears its violent heart on its sleeve. Jupiter's moon Io is a cosmic furnace, the single most volcanically active place we have ever found. Its surface is a chaotic canvas of fiery oranges, brilliant yellows, and deep blacks, a color scheme painted by hundreds of active volcanoes. These are not dormant mountains, but constantly erupting vents, spewing fountains of molten rock and towering plumes of sulfur hundreds of miles high into the vacuum of space. This relentless activity completely resurfaces the moon, erasing impact craters almost as soon as they form with fresh layers of lava and volcanic frost. The engine for this hellish landscape is not internal heat from a radioactive core, but an external gravitational tug of war. Io is caught in an orbital dance between the massive gravity of Jupiter and the rhythmic pulls from its sister moons Europa and Ganymede. This constant, intense flexing generates immense friction inside Io, heating its interior like a ball of clay being repeatedly kneaded. Spacecraft like Galileo and more recently Juno have captured stunning images of this inferno, showing vast lava lakes and umbrella-shaped eruption plumes silhouetted against the moon's mottled face. It is a world perpetually tearing itself apart and rebuilding itself, a stark reminder that the forces shaping our solar system are not always gentle. That same cosmic violence that forged Io stands in stark contrast to the serene beauty of our solar system's most famous jewel. Saturn's magnificent rings, those pristine icy bands, are not ancient relics from the birth of the planet. They are a surprisingly recent addition, a fleeting spectacle in the grand timeline of our solar system. For a long time, it was assumed these rings were as old as Saturn itself, a staggering 4.5 billion years. But data from the Cassini spacecraft, which spent 13 years studying the giant planet, revealed something astonishing. By carefully measuring the mass of the rings and analyzing how they were being polluted by a constant rain of micrometeoroids, scientists concluded the rings are likely only between 10 and 100 million years old. This means that when the mighty Tyrannosaurus Rex walked the Earth, Saturn may have been a plain, ringless world. Their formation was a cosmic event that happened in what amounts to a mere blink of an eye. The leading theories point to a dramatic catastrophe, perhaps a comet that wandered too close and was torn apart by Saturn's immense gravity, or more likely, the destruction of a former icy moon. This moon could have shattered from a collision with another object or been ripped apart by the planet's tidal forces, its debris spreading out into the beautiful, orderly disk we see today. This revelation makes their beauty feel profoundly temporary. We are not looking at a permanent feature of the solar system, but a brilliant, short-lived performance. A celestial dance of ice and dust that we are extraordinarily lucky to witness in its brief, glorious prime. This strange cosmic clockwork is not unique to the giant planets. Mercury, the sun-scorched innermost world, operates on a schedule that defies all earthly logic. A single day here from one sunrise to the next lasts longer than the entire trip around the sun. Think about that for a moment. If you were standing on the surface of Mercury, you would celebrate 2 of the planet's years before you even experienced one full day. The reason for this bizarre timekeeping lies in a strange orbital dance. Mercury is a world of extremes, spinning on its axis very slowly while simultaneously whipping around the sun at a breathtaking speed. It completes one orbit, one Mercurian year, in just 88 Earth days. However, its rotational day, the time it takes to spin around once, is 59 Earth days. This slow spin combined with its incredibly fast orbit creates a solar day, the actual experience of sunrise to sunrise that stretches for 176 Earth days. Picture a slow runner on a very small, fast-moving track. By the time they have turned around once, they have already lapped the track multiple times, and the sun appears to move backwards in the sky. For a person on Mercury, the sun would rise, then appear to slow down, stop, and even reverse its course before setting again many Earth weeks later. It is a world where time itself seems to have come undone, a place where a year is just a brief season in an endlessly long and scorching day. Even as Mercury defies our understanding of time, our own moon holds a secret that transforms it from a barren world into a treasure chest. Hidden in the profound, permanent shadows of its polar craters lies water, frozen solid in the eternal darkness. These are some of the coldest places in the entire solar system, where sunlight has not reached for billions of years, creating perfect deep freezes for trapping water ice delivered by ancient comet impacts. For a long time, we saw the moon as a completely dry, dusty rock, but this discovery changes everything. It turns a destination into a potential gas station. This water is not just for drinking, it is a resource that can be broken down into its basic components, hydrogen and oxygen, the very same elements that power rocket engines. The implications are staggering. Future lunar bases could mine this ice, using the water to sustain astronauts and manufacture fuel for spacecraft heading deeper into the solar system. This vision became a confirmed reality thanks to missions like NASA LCROSS, which deliberately crashed a rocket stage into a shadowed crater at the South Pole, analyzing the plume of ejected material and confirming the presence of significant water ice. Its companion, the Lunar Reconnaissance Orbiter, has since mapped these frozen deposits in exquisite detail. The moon is no longer just a destination, it is a stepping stone, a cosmic pit stop whose darkest corners hold the key to a brighter future in space. Far out in the frigid darkness, Neptune defies all expectations of a world so distant from the sun. This ice giant, receiving only a faint whisper of solar warmth, somehow glows with an intense inner fire. Neptune actually radiates more than twice the heat it absorbs from our star, a paradox that has puzzled scientists since its discovery. The sun's energy at that range is feeble, like a single candle placed 30 feet away, yet the planet itself is a powerhouse. So where does all this extra energy come from? The leading theory points to the planet's violent birth. When Neptune formed 4.5 billion years ago, it was assembled from countless collisions of rock and ice, a process that generated an immense amount of primordial heat. That initial furnace has been slowly cooling ever since, with the planet still releasing that leftover thermal energy into space. Another piece of the puzzle is gravitational compression, the slow, relentless sinking of heavier elements toward the planet's core. This constant internal rearrangement, like a planet slowly settling in on itself, generates friction and heat through a process known as the Kelvin-Helmholtz mechanism. There is also the possibility of radioactive decay deep within a rocky core, providing a steady, simmering source of power. Neptune is not a cold, dead world passively reflecting sunlight, but a dynamic body with its own powerful internal engine, actively shaping its wild weather and supersonic winds from the inside out. One of humanity's greatest eyes on the cosmos nearly failed before it could truly see. When the Hubble Space Telescope was first launched in April of 1990, the world held its breath for the universe's sharpest portraits. Instead, the initial images it sent back were heartbreakingly blurry, a cosmic masterpiece painted hopelessly out of focus. A devastating investigation revealed the cause, a flaw in the telescope's primary mirror, a perfect piece of glass polished with an excruciatingly small but catastrophic error. The mirror was too flat at its edges by just 1/50th the width of a human hair, a minuscule mistake that scattered the light from distant stars and made detailed science impossible. For 3 years, Hubble became a symbol of a billion-dollar failure, a punchline for late-night comedians and a source of deep embarrassment for NASA. Yet this story of human error was about to be rewritten by an even more incredible story of human ingenuity. Engineers devised a radical fix, a set of corrective optics and new instruments that would function like a pair of extremely sophisticated eyeglasses for the telescope. The plan was as audacious as it was risky, a servicing mission that would send astronauts to perform 5 days of complex spacewalks to install this corrective hardware. In December of 1993, the Space Shuttle Endeavour rendezvoused with the ailing telescope. The world watched as astronauts working in the unforgiving vacuum of space successfully captured Hubble and performed the delicate surgery. They replaced the camera and installed the corrective optics unit with its 12 tiny mirrors, a procedure that required absolute precision. When the first new images were beamed back to Earth, the effect was instantaneous and breathtaking. The blur was gone, replaced by the crystal-clear, jaw-dropping vistas of nebulae and galaxies that have since become legendary. This was not merely a repair, it was a transformation. Hubble went from a symbol of failure to the most productive scientific instrument ever built, a triumph of perseverance that rewrote our understanding of the universe and proved that even our greatest stumbles in space can be overcome with brilliant engineering and sheer human courage. Even the most enduring cosmic storms are not immune to the passage of time. Jupiter's great red spot, a swirling crimson tempest large enough to swallow our entire planet, has been a constant feature of the solar system for at least 4 centuries. This colossal hurricane, with winds screaming at speeds over 200 miles per hour, has long been the very definition of permanence in a chaotic atmosphere. Yet we are now witnessing its slow and mysterious decline. For over a century, astronomers have been carefully measuring this giant, and the data reveals an undeniable trend. The storm is shrinking. What was once a vast oval that could comfortably fit 3 Earths side by side has now narrowed to a shape barely wider than our single world. Time-lapse images pieced together from missions like Voyager, Galileo, and Juno show a dramatic visual transformation. The iconic storm is not just getting smaller, it is also changing shape, becoming more circular, almost as if it is being squeezed by the very atmospheric currents that sustain it. This raises a profound and unresolved question for planetary scientists. Are we watching the final act of a legendary storm, a slow and steady dissipation into the turbulent clouds of Jupiter? Or is this a natural cycle, a contraction before some unknown atmospheric process allows it to stabilize or even regrow? The answer remains hidden within the complex fluid dynamics of Jupiter's deep atmosphere. We are left as spectators to a celestial drama unfolding in slow motion, a reminder that even the giants of our solar system are ever-changing, their futures written in the language of wind and cloud. Far from the churning clouds of Jupiter, a different kind of storm echoes through the void, one that sings. The space around our own planet is alive with an eerie chorus of radio waves known as whistlers. These are not signals from some alien intelligence, but a natural and haunting symphony generated by our own world. It begins with a simple lightning strike. A colossal bolt of electricity during a terrestrial thunderstorm doesn't just flash and roar. It also unleashes a broad burst of electromagnetic energy, a pulse of radio waves that shoots up into the upper atmosphere. If conditions are just right, this energy can escape Earth's grasp and become trapped by our planet's magnetic field lines. The radio waves then race along these invisible magnetic highways, traveling from one hemisphere to the other, sometimes bouncing back and forth for thousands of miles. The lower frequency parts of the wave travel slightly slower than the higher frequencies through this magnetized plasma. This dispersion effect stretches the initial sharp crackle of the lightning into a descending tone, a pure electronic whistle that slides down the scale. The result is a sound that feels pulled straight from a science fiction film, a falling glissando that lasts for a second or two, often described as a laser beam from an old space opera. You are about to hear a real recording of these space whispers, a sound captured by satellites and scientific instruments, a ghostly melody composed by our own planet and played on the strings of its magnetic field. The sound of a whistler is a direct link between the raw power of a terrestrial storm and the silent, magnetic architecture of space, a reminder that even in the vacuum, our world makes its presence known. That same magnetic field that conducts Earth's ghostly chorus is dwarfed by the forces at work on our star, where a scientific paradox burns with ferocious intensity. The surface of the Sun is a seething ocean of plasma, a roiling inferno that reaches a temperature of about 10,000 degrees Fahrenheit. It is a heat so profound it defines our very concept of hell. Yet, if you travel upward from that brilliant surface, moving into the Sun's outer atmosphere, the corona, something impossible happens. The temperature doesn't drop, it skyrockets, soaring to millions of degrees. This is the coronal heating problem, one of the most enduring and counterintuitive mysteries in all of astrophysics. Think of it as walking away from a bonfire, and instead of getting cooler, you suddenly step into a furnace 1,000 times hotter. It completely defies common sense. How can the Sun's atmosphere be so much hotter than the surface it surrounds? The answer lies not in the fire of the Sun's core, but in the invisible architecture of its magnetic field. The Sun is not a solid ball, but a spinning, tangled knot of magnetic forces. One leading theory suggests the corona is heated by countless tiny explosions called nanoflares. These are not the massive solar flares we observe, but trillions of miniature eruptions, each a magnetic reconnection event where tangled field lines snap and realign, releasing a burst of energy. Individually, each nanoflare is small, but their collective, ceaseless popping could provide the immense heat that cooks the corona. Another compelling idea points to magnetic waves. The churning plasma at the Sun's surface sends powerful vibrations racing along the magnetic field lines, like someone violently shaking a massive rope. As these waves travel upward into the less dense corona, their energy compresses and dissipates as heat, a constant, roiling transfer of power that superheats the atmospheric gas. We see the beautiful evidence of this during a total solar eclipse, when the moon blocks the blinding photosphere. The ethereal, pearly white corona shimmers into view, its delicate, streaming structure a direct map of the Sun's complex magnetic field. This isn't just a pretty light show, it is the visual signature of a million-degree atmospheric engine, a cosmic riddle written in magnetized fire that we are only just beginning to decode. Our solar system contains a world spinning on its side. Uranus is tilted so dramatically that its axis lies almost parallel to its orbit, a 98-degree lean that makes it appear to roll around the Sun like a celestial ball. While every other planet spins with a certain upright dignity, Uranus is tumbling through its orbital path. This extreme orientation creates seasons of almost unimaginable length and intensity. Picture the North Pole of Uranus pointing directly at the Sun for an unbroken stretch of 42 Earth years. During this time, that entire hemisphere is bathed in perpetual daylight, a single, endless summer. Then, as the planet continues its 84-year journey around the Sun, the poles slowly swap roles. The North Pole swings into a 42-year-long night of total darkness, a deep freeze of unimaginable cold, while the South Pole begins its own multi-decade summer. This is a seasonal cycle on a scale that dwarfs human comprehension. The leading explanation for this bizarre configuration is a catastrophic event from the solar system's violent youth. Astronomers theorize that a protoplanet, a young world roughly the size of Earth, slammed directly into Uranus in a colossal impact. This was not a glancing blow, but a head-on collision powerful enough to knock the entire planet onto its side, fundamentally altering its spin and the orientation of its entire system of rings and moons. The evidence for this impact is written in the planet's own strange behavior, a permanent cosmic scar from a time of chaos, forever locking this ice giant in its unique and lopsided dance. Yet the profound silence of space is another cosmic myth waiting to be shattered. We are taught that in the vacuum, no one can hear you scream, and this is technically true for the pressure waves our ears are built to detect. But to call space silent is like calling the ocean floor barren because there are no trees. Space is not empty, it is filled with a thin, electrified gas known as plasma, and this seething sea of charged particles is constantly vibrating with electromagnetic energy. These are not sound waves, but they can be translated into sound, revealing a universe alive with an invisible symphony. Our robotic explorers have been listening in for decades. The Voyager probes, as they crossed the turbulent boundary of the Sun's influence known as the heliopause, recorded the chaotic crackle and hum of plasma waves crashing against the interstellar medium. Another probe, NASA Van Allen Belt's mission, captured something even more eerie, a chorus of chirps and whistles created by energetic particles dancing along Earth's own magnetic field lines. Scientists convert these radio emissions into audio we can hear, shifting the frequencies down into the range of human hearing. The result is a soundscape that is both alien and strangely familiar. You are about to hear one of these converted recordings, the actual vibrations of space itself. Listen to the rising and falling tones, the pops and static hiss. This is the voice of the solar wind, the whisper of a distant magnetic storm, the true sound of the cosmos. It is a haunting reminder that the universe is never truly quiet. It is only waiting for us to learn how to listen. One of Hubble's most iconic portraits is a celestial lie, a beautiful echo of something that may no longer exist. The pillars of creation, those three towering columns of cosmic dust and gas reaching through the Eagle Nebula, are a vision of stellar birth. Yet the very light that paints their image for us carries a tragic secret. This nebula is 7,000 light-years away, a distance so vast that the light captured by Hubble's camera spent 7,000 years traveling across the void to reach us. We are not seeing the pillars as they are now, but as they were when human civilizations were first laying their foundations. We are looking into a deep and profound past. And in that past, astronomers have found evidence of a coming apocalypse. A nearby massive star was poised to go supernova, and the violent shockwave from such an explosion would have been like a cosmic tsunami, sweeping through the delicate structures at millions of miles per hour. The pillars, composed of gas and dust that is far less dense than our Earth's air, would have been utterly shredded and scattered by the blast. Calculations based on the observed expansion of the supernova's shock front suggest this demolition likely happened about 6,000 years ago. The pillars were probably vaporized a millennium before the pyramids of Giza were built. We are left gazing at a ghost, a magnificent memory frozen in starlight. The evidence of their destruction is already racing toward us, a wave of light carrying the news of their end. But traveling at the universe's speed limit, it will not arrive for another 1,000 years. This is the ultimate cosmic irony, a reminder that the universe is a dynamic and violent place, and that our most beautiful windows into the heavens are also portals to a past we can never touch. Those ghostly sounds of space are a universe away from the simple human act of crying. But in the weightless environment of space, even the most fundamental human experiences are transformed into something alien. An astronaut's tears do not fall. Without the constant downward pull of gravity, the physics of sorrow are rewritten. When an astronaut cries, the tears do not trace a path down their cheek. Instead, they pool right at the eye, gathering into a growing, quivering bubble of saline fluid. This wobbly sphere clings to the face through surface tension, a force that becomes dominant in microgravity, creating a liquid lens that blurs vision. It can be a deeply uncomfortable sensation, a constant, watery pressure against the eyeball that refuses to be blinked away. The simple relief of wiping away a tear is gone, replaced by the need to carefully dab the fluid with a cloth before the bubble grows too large. The situation can shift from merely strange to genuinely hazardous. If that tearful sphere breaks free from the eye's surface tension, it does not drop to the floor. It floats. A single salty teardrop becomes a free-flying liquid orb, drifting through the cabin of the International Space Station. This is not just an inconvenience, it is a potential threat to sensitive electronics and air filtration systems. Footage from the ISS shows astronauts carefully managing these floating fluids, a constant reminder that in space, the most intimate human moments must be consciously controlled, turning a universal expression of emotion into a delicate and precarious physical phenomenon. That same physics that holds tears in place on an astronaut's face also paints the Martian sky in a color we would find utterly alien. On Mars, the sun sets in a cool, haunting shade of blue. While our own sunsets blaze with fiery reds and deep oranges, the Martian horizon offers a serene, ethereal glow, a soft blue halo surrounding the diminished sun. This dramatic reversal is a direct consequence of the Martian environment itself. Earth's thick atmosphere, rich with nitrogen and oxygen molecules, scatters the shorter blue wavelengths of sunlight in all directions, which is why our daytime sky is blue. At sunset, when sunlight travels through a much thicker slice of that atmosphere, the blue light is scattered away from our line of sight, allowing the longer, redder wavelengths to dominate the sky. Mars plays by a completely different set of rules. Its atmosphere is incredibly thin, just 1% the density of our own, and it is filled with very fine, iron-rich dust constantly suspended in the air. These tiny dust particles are perfectly sized to scatter the longer, red wavelengths of light outward. This leaves the shorter blue light to travel more directly through the dusty haze toward an observer's eyes. So as the sun dips below the Martian horizon, the area immediately around it fills with a tranquil, luminous blue, while the rest of the sky takes on a muted, reddish-brown hue from the scattered red light. We have seen this otherworldly spectacle through the electronic eyes of our robotic explorers. Rovers like Curiosity and Perseverance have repeatedly turned their cameras toward the setting sun, capturing high-definition images of these beautiful blue twilights. To see the two sunsets side by side is to witness the profound influence of a world's very character on its most simple, daily wonders. One is a fiery farewell, the other a cool, quiet adieu, each a perfect signature written in light across an alien sky. While our robots on Mars and our telescopes in orbit speak the language of data, humanity has also sent a message in a far more personal bottle out into the cosmic sea. The Voyager 1 and Voyager 2 probes each carry a golden time capsule, a 12-inch gold-plated copper disc known as the Golden Record. It is less a scientific instrument and more a letter to the future, a gift for any intelligence that might one day find this silent traveler in the emptiness between stars. The record's contents were curated by a team led by the visionary astronomer Carl Sagan, a deliberate attempt to capture the essence of our world. It contains 115 analog encoded photographs and a vast collection of sounds. There are the natural symphonies of Earth, the crash of ocean waves, the songs of whales, the rumble of volcanoes, and the whisper of wind and rain. It holds the diverse tapestry of human culture, with spoken greetings in 55 ancient and modern languages, and music ranging from the driving rhythms of Chuck Berry to the profound complexities of Bach. There are also the intimate, universal sounds of a human heartbeat, a mother's kiss, and the laughter of a child. Etched on the record's cover are symbolic instructions, a cosmic play button explaining its origin, and how to decode its contents using the cartridge and needle stored alongside it. The diagrams point to our Sun's location relative to 14 pulsars, a celestial map that would remain valid for hundreds of millions of years. Creating this record was a monumental act of hope, a decision to represent all of humanity in a single artifact to say, we were here, this is what we sounded like, and we dreamed of reaching out to you. That same hope we cast toward the stars now faces a growing threat from our own carelessness, a shell of our own making that encircles the entire planet. Earth's orbit has become a cosmic junkyard, a chaotic swarm of debris traveling faster than a speeding bullet. This is not just a few old satellites, it is a cloud of millions of pieces, from defunct spacecraft and spent rocket stages down to tiny fragments of shattered metal and flecks of paint. Each piece, no matter how small, is a potential bullet. In the vacuum of space, objects orbit at staggering velocities, around 17,500 miles per hour. At that speed, a paint chip carries the kinetic energy of a bowling ball thrown at 60 miles an hour, while a metal bolt the size of a fist hits with the force of a hand grenade. This ever-growing cloud poses a direct and constant danger to everything we have in space, from the International Space Station, which must regularly perform maneuvers to avoid tracked debris, to the vital satellites that provide our weather forecasts, global communications, and GPS navigation. A single collision can be catastrophic, not just destroying a satellite but creating thousands of new fragments, each one a new threat in a cascading chain reaction known as the Kessler syndrome. This scenario paints a terrifying future where low Earth orbit becomes so littered with shrapnel that it is effectively impassable, trapping us on our own planet. The problem is no longer theoretical, we are already living with its consequences. Solutions are now a critical priority, ranging from new international guidelines that require satellites to deorbit at the end of their lives to ambitious plans for active debris removal. These concepts involve robotic missions that could capture large pieces of junk with nets or harpoons, or use lasers to nudge them into decaying orbits where they will safely burn up in the atmosphere. Visualizing this problem reveals a sobering truth. Our planet is now wrapped in a fragile and increasingly dangerous shell, a testament to our ambition that we must now learn to clean up before it becomes our cage. Perhaps the most persistent lunar myth is the idea of a permanent dark side. In truth, the moon has no such place. It has a far side, the hemisphere forever hidden from our view, but it is bathed in just as much sunlight as the side we know. This cosmic coincidence is due to a state called tidal locking. Over billions of years, Earth's gravitational pull has acted like a gentle brake, slowing the moon's rotation until it perfectly matches its orbit around our planet. The moon still spins, but it does so at the exact same rate it revolves, completing one rotation for every single trip around Earth. This elegant orbital dance means we are forever destined to see only one familiar face, a cosmic partner that never turns its back on us. Yet this hidden hemisphere is not a mirror of the near side we see in our night sky. When the first images were radioed back by the Soviet Luna 3 probe in 1959, they revealed a world shockingly different from the one we knew. The far side is a rugged, battered landscape pockmarked with craters and almost completely lacking the vast, dark plains of ancient lava we call maria or seas. This stark geological divide remains a profound puzzle. The leading theory suggests the far side's crust is significantly thicker, a result of how the moon cooled and solidified eons ago. This thicker armor may have made it more difficult for molten rock from the interior to erupt through and flood the basins created by giant impacts, leaving the far side a preserved record of the solar system's violent early bombardment. Our exploration of this hidden realm took a giant leap with China's Chang'e 4 mission, which in 2019 became the first spacecraft to make a soft landing on the far side. Its rover U-22 has been exploring the floor of the Von Karman crater, a site within the immense South Pole Aitken Basin, one of the largest and oldest impact scars in the entire solar system. The data it has sent back, from soil composition to temperature readings, is slowly peeling back the layers of this lunar enigma. We are no longer staring at a mythical dark side, but actively exploring a real and geologically distinct world, a testament to how much we still have to learn about our closest celestial neighbor. The silent menace of orbital debris is a danger we created ourselves, but a more intimate biological threat has been discovered growing right inside our spacecraft. Some bacteria do not just survive in space, they thrive, becoming far more dangerous versions of themselves. In the microgravity environment of the International Space Station, common microbes like Salmonella, a frequent cause of food poisoning on Earth, have been observed undergoing a terrifying transformation. They do not merely live in the weightless culture, they actively become more infectious and more virulent. In a series of landmark experiments, astronauts grew Salmonella bacteria in specialized hardware, comparing them to identical cultures grown back on Earth. The results were alarming. The space-grown Salmonella was almost 3 times more likely to cause disease in laboratory mice. The microgravity environment was somehow tricking the bacteria into turning on a master genetic switch, altering the expression of 167 of its genes and making it far better at causing infection. The bacteria essentially became supercharged, honing their ability to invade host tissues and resist the body's natural defenses. This phenomenon, nicknamed the space bug effect, is a clear and present danger for astronaut health, especially on long-duration missions to the Moon or Mars, where a simple infection could become a mission-ending crisis. Yet this unsettling discovery also opens a remarkable door for medical science. By studying exactly how microgravity triggers this hypervirulence, scientists are gaining unprecedented insight into the fundamental mechanics of how bacteria make us sick. They have already identified a key protein, HFQ, that acts as a genetic regulator in this process. This knowledge is a direct roadmap for developing new vaccines and treatments that could target that same protein or pathway back on Earth. The peril of a stronger space germ has thus become an unexpected key, unlocking secrets of disease that could protect all of humanity. Our own Milky Way is not an island universe destined for eternal solitude. It has a partner in a dance of cosmic proportions, and the music is about to change. The Andromeda galaxy, that faint, smudged spiral in our night sky, is not standing still. It is rushing directly toward us at an astonishing speed of 110 kilometers every single second. This is not a random drift, it is a gravitational embrace that has been building for billions of years. The 2 largest galaxies in our local group are on an inescapable collision course. In approximately 4.5 billion years, they will meet. The word collision conjures images of stellar fireballs and planetary destruction, but the reality of a galaxy merger is far stranger and more beautiful. The vast emptiness within galaxies makes a direct hit between stars almost impossibly rare. The average distance between stars is so immense that if they were the size of grains of sand, they would be separated by miles of empty space. So when the Milky Way and Andromeda intermingle, their stars will mostly pass right through the vast gaps in each other's formations, like two ghostly crowds walking through one another. The real drama unfolds not with the stars themselves, but with the invisible architecture that binds them, the immense clouds of gas and dust that fill the galactic space. As the galaxies swing past and through each other in a series of gravitational close calls, these cosmic clouds will slam together. This violent compression will trigger a firestorm of new star birth, a stellar baby boom that will light up the skies of any surviving worlds with countless new suns. Supercomputer simulations of this event paint a breathtaking picture. The two spiral structures will be stretched and warped beyond recognition, their elegant arms pulled into long, streaming tails of stars. They will then swing back around, their mutual gravity pulling them into a final, slow merger. After a billion-year-long celestial ballet, they will settle into a new, larger galaxy, most likely a featureless elliptical blob. Our familiar Milky Way as a distinct spiral will be gone, transformed into something entirely new. For any life that exists then, the night sky will be a spectacle of unimaginable scale, filled with the blended light of two united galaxies, a single, colossal island of stars born from a gentle cosmic collision. The most iconic images in human history are not what they seem. That grainy, black and white footage of Neil Armstrong taking his first step on the moon was actually a copy of a copy, a ghost of the original. The true high-definition record of that moment was lost, a victim of bureaucratic oversight and a simple lack of blank tapes. Here is what happened. The live television broadcast sent to the world came from a small camera on the lunar module, but its unique signal format could not be transmitted directly to television networks. It had to be pointed at a special monitor in Houston, and a conventional broadcast camera was then used to film that monitor screen. This kinescope process, essentially taking a video of a video, is what created the blurry, low-contrast images etched into our collective memory. Meanwhile, the pristine, raw, high-quality feed from the moon was being simultaneously recorded onto 1-inch analog data tapes. These reels contained the uncompressed, sharp video, a master recording of one of our greatest achievements. For years, these tapes sat in a government archive. Then, in the 1980s, NASA needed more magnetic tapes for new satellite missions. Facing a shortage and believing the broadcast copies were sufficient for history, a fateful decision was made. The original Apollo 11 moonwalk tapes, along with thousands of other reels, were erased and reused. The master recording was wiped clean to record satellite weather data. The realization of this loss sparked a multi-year, multi-million-dollar hunt. A team of engineers and archivists launched an official search, scouring NASA facilities and tracking old records, hoping a set of the original tapes had been misfiled and forgotten. They never found them. The search did, however, lead to a remarkable restoration project. Using the best surviving copies, including a rare and slightly better broadcast recording discovered in Australia, experts digitally scrubbed the footage. They reduced the noise, corrected the contrast, and sharpened Armstrong's ghostly figure, giving us the clearest version we will likely ever have. It is a bittersweet legacy, a reminder that our reach for the stars is sometimes tripped up by the most mundane of earthly problems, a simple shortage of shelf space. The story of our reach into the cosmos is written not just in metal and fire, but in the heartbeat of a small, stray dog. Before any human had ever felt the shudder of a rocket launch, a gentle mixed breed named Laika was chosen to prove that life could survive the journey to orbit. She was plucked from the streets of Moscow, a calm and resilient candidate deemed perfect for the Soviet Union's audacious mission, Sputnik 2. In November of 1957, just a month after the first Sputnik had stunned the world, Laika was sealed inside a cramped, pressurized cabin. Her vital signs were wired to transmitters, the only connection to a living soul ascending into the complete unknown. The launch was a success, and Laika became the first creature to ever circle our planet. But this triumph was shadowed by a grim, predetermined fate. The technology to bring a spacecraft safely back through the atmosphere simply did not exist. The engineers who petted her and gave her a name knew from the beginning that she would not be coming home. Her mission was a one-way trip, a sacrifice designed to gather the crucial data needed to make human spaceflight possible. For years, the official story was that she lived for several days, but the truth, concealed until much later, was far more heartbreaking. Due to a thermal control system failure, the capsule overheated dramatically, and Leica perished from stress and heat exhaustion mere hours into her flight. Her legacy is a profoundly complex one, a mix of pioneering courage and deep ethical conflict. She proved that a living being could withstand the forces of launch and the initial moments of weightlessness, data that directly paved the way for Yuri Gagarin's historic orbit. Yet her story forces us to confront the difficult costs of exploration, the price paid in silent suffering for our giant leaps. She was a good dog, an unwitting pioneer whose memory remains a poignant and essential chapter in our journey to the stars. That same delicate control needed to manage a floating tier is practiced on a grand scale here on Earth, in the closest thing we have to a zero-gravity gymnasium. Astronauts prepare for their spacewalks not in a vacuum, but submerged in the deep end of some of the largest swimming pools on the planet. These are not ordinary pools, they are neutral buoyancy laboratories, and they offer the most accurate simulation of weightlessness we can create without leaving the ground. The principle is elegantly simple. By carefully adjusting the amount of weight and buoyancy on an astronaut and their suit, engineers can make them hover perfectly in the water column, neither sinking nor rising. This neutral buoyancy state mimics the feeling of floating in space, allowing for hours of uninterrupted practice. An astronaut, fully suited in a pressurized 300-pound spacesuit, will descend into the 40-foot deep water. Below the surface lies a full-scale, meticulously detailed replica of the International Space Station's exterior, complete with every handrail, cable connector, and scientific experiment they might encounter in orbit. Here, they rehearse their entire spacewalk, from the precise choreography of moving hand over hand to the complex ballet of replacing a faulty pump or installing new hardware. Every tool is tethered, every motion is planned, and every potential problem is encountered and solved in the relative safety of the water. A team of divers is always nearby, acting as safety observers and cameramen, while flight controllers in a nearby room communicate with the astronaut just as they would from mission control during a real spacewalk. This grueling underwater training is where muscle memory is forged. It is where an astronaut learns the exact amount of force needed to turn a bolt without sending their own body spinning in the opposite direction, a perfect demonstration of Newton's third law. They learn to manage the suit's resistance and the disorienting lack of up or down. A 6-hour spacewalk in orbit might require dozens of 6-hour training sessions in the pool, building the kind of ingrained confidence that turns a potentially terrifying venture into a routine procedure. It is a testament to human ingenuity, using the simple physics of buoyancy to conquer the profound challenges of the vacuum. The hunt for a ninth planet is a modern astronomical detective story, a case built not on a photograph but on a gravitational signature. Far beyond the orbit of Neptune, in the frozen outskirts of our solar system, a collection of small, icy bodies is behaving strangely. These distant denizens of the Kuiper belt, a realm of primordial leftovers, follow wildly elongated orbits that seem to cluster together in a way that defies random chance. Their paths are tilted, grouped in a manner that suggests they are all being shepherded by the same invisible force. The most plausible explanation, proposed by astronomers at Caltech, is the gravitational pull of a massive, unseen planet. This hypothetical world, nicknamed Planet 9, would not be a small rocky body like Pluto, but a true giant, a super-Earth or a mini-Neptune with a mass up to 10 times that of our own world. Its own orbit would be a long, slow ellipse, swinging hundreds of times farther from the Sun than Earth, taking perhaps 10,000 or even 20,000 years to complete a single journey around our star. Finding this ghost world is the monumental challenge. Its incredible distance means it reflects virtually no sunlight, making it a desperately faint pinprick in an unimaginably vast expanse of sky. The search is focused using the most powerful telescopes we have, like the Subaru telescope in Hawaii, which methodically scans the most likely patches of the heavens for this elusive moving point of light. This is not a search for something we have seen, but for something we can feel, a cosmic presence revealed only by its subtle tug on the tiny worlds at the edge of everything we know. Those iconic stars and stripes planted on the lunar surface are almost certainly gone. The 6 American flags left by the Apollo astronauts have been standing in an environment far more hostile than any desert on Earth. They are battered by unfiltered, relentless solar radiation, a barrage of ultraviolet light that strikes the moon's surface with nothing to soften its blow. Our atmosphere acts as a protective shield, absorbing and scattering most of this damaging UV light before it reaches us. On the airless moon, the flags are exposed to the sun's full fury. This intense radiation is a powerful bleaching agent, breaking apart the chemical bonds in the dyes that give the flags their vibrant reds and deep blues. Over the decades, this constant exposure has systematically stripped the color away. Scientists who have studied the degradation of materials in space believe the flags are now almost certainly pure white, their patriotic patterns faded into a blank canvas. They might even be in tatters, their fabric weakened and brittle from the extreme temperature swings, cycling from blistering heat to deep cold every 2 weeks. It is a quiet, poetic transformation. Those symbols of a specific national achievement have been slowly rewritten by the impartial hand of physics, their human message fading until all that remains is a simple, stark white banner, a universal signal of truce or surrender silently waving on an airless world. The human heart, shaped by a lifetime of fighting gravity, begins to change its very form when that constant force disappears. In the weightless environment of space, the heart no longer struggles to push blood from your legs and abdomen up to your brain. That heroic daily effort against Earth's pull simply vanishes. Freed from this perpetual labor, the heart muscle begins to adapt, and one of the most startling changes is that it becomes more spherical. Over a period of several months in orbit, the heart remodels itself, losing significant muscle mass and shifting from its familiar, efficient, elongated shape to something closer to a ball. Astronauts on the International Space Station have participated in studies using advanced ultrasound machines to track this transformation in real time, confirming a subtle but profound alteration to one of our most vital organs. This spherical shift is not just a curiosity, it is a potential medical concern. A more rounded heart may not pump blood as effectively, and the loss of cardiac muscle is similar to what doctors see in patients with certain forms of heart failure back on Earth. The heart, in essence, gets lazy without gravity's constant workout. This research is absolutely critical for the future of human spaceflight, especially for a multi-year mission to Mars. Engineers can design a ship to get astronauts there, but we must also ensure their hearts are strong enough to function upon arrival, and more importantly, after they return to the heavy grip of Earth's gravity. Yet this cosmic cardiac puzzle has a powerful silver lining for all of us. By studying how and why the heart weakens in space, scientists are gaining unprecedented insight into the fundamentals of cardiovascular disease. They are essentially using microgravity as a unique laboratory to accelerate the conditions of heart aging and deconditioning. The countermeasures developed for astronauts, like specialized vacuum pants that pull blood into the lower body or rigorous, tailored exercise regimens, are directly informing new rehabilitation techniques for Earth-bound patients who are bedridden or suffering from heart conditions. The journey to Mars is not just about reaching another world, It is about unlocking the secrets of our own bodies, proving once again that the challenges of space exploration often deliver their greatest rewards right here at home. Every discovery we have made, from the moon's scent to the fate of merging galaxies, exists within a cosmic reality we can barely perceive. The planets, stars, and brilliant nebulae, everything we have ever seen with our eyes or our most powerful telescopes, is merely the visible frosting on an unimaginably vast and mysterious cake. In truth, all of that normal matter, the stuff that makes up you, me, and every star in the sky, accounts for less than 5% of the entire universe. The remaining 95% is composed of two profound and invisible unknowns, dark matter and dark energy. Dark matter, making up about 27% of the cosmos, is the hidden scaffolding. We cannot see it or touch it because it does not interact with light in any way, yet we know it must be there because of its immense gravitational pull. Galaxies spin so fast that they should fly apart, but something with tremendous mass holds them together, an invisible glue we call dark matter. Then there is dark energy, an even more baffling force that constitutes a staggering 68% of the universe. In the late 1990s, astronomers made a shocking discovery. The expansion of the universe is not slowing down, it is accelerating. Something is actively pushing space itself apart, and we have named this repulsive force dark energy. So the universe we call home is a place where the familiar is the exception, a tiny island of light in a sea of invisible forces. The grandest quest in modern physics is to understand this dark cosmos, to uncover the nature of the 95% of reality that remains the ultimate, humbling mystery. From the fading flags on the moon to the silent symphony of space, these 30 glimpses reveal a profound truth. Our journey into the cosmos is far more than a technical checklist. It is a story written in equal parts by human courage and cosmic absurdity, a narrative where scientific triumph sits beside haunting mystery. We have seen how our own bodies reshape themselves in the void and how our machines become quiet monuments on alien worlds. We have learned that the universe is not a silent, static painting, but a dynamic, roaring arena of invisible forces and violent beauty. Every fact, from the temporary height of an astronaut to the impending galactic collision, reshapes our understanding of our place in this vast expanse. This is the grand tapestry of exploration, woven with threads of ingenuity, wonder, and a relentless curiosity that pushes us to look beyond the horizon. So the next time you find yourself under a clear night sky, take a moment to truly look up. Let your eyes wander to the pinpricks of light and the dark spaces between them. Remember the whispers of radio waves, the taste of gunpowder on lunar dust, and the heart that beats differently among the stars. Then tell us which of these wonders resonated most with you. Share your favorite fact in the comments below, and if you are hungry for more journeys into the unknown, subscribe to keep exploring right alongside us. The universe has only begun to share its secrets.